Hello guys, welcome back to my YouTube channel. Today I'm going to solve day 16 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I'm going to solve problem number 2096, step-by-step directions from a binary tree node to another. Okay, so in this problem you are given the root of a binary tree with n nodes, and each node is uniquely assigned a value from 1 to n. Okay, so see this example 1. So here in total, how many nodes are there? 1 2 3 4 5 6, total 6 nodes, and see the numbering 1 to 6, right? Okay, and you are also given an integer start value representing the value of start node s, and a different integer destination value representing the value of the destination node t. Okay, so start value and destination value given to us. So from 3 I need to move to the 6. Okay, and we have to find the shortest path from moving from our start node to the destination node. Okay, so we have to generate step-by-step directions of such path as a string consisting of only the uppercase letters L. L means to go from a node to its left child node. R means to go from a node to its right child node, and U means to go from a node to its parent node. Okay, and we have to turn the step-by-step directions of the shortest path from node S to T. Okay, so see here, start value is 3 and destination value is 6. Okay, so from 3 I am moving up. Okay, so 3 is the child and 1 is the parent. Okay, so from child I am moving to parent, so that is why I am writing U here. Then from 1 I am moving to 5, right? This is child and this is parent, so here I am writing U. Then from 5 I am moving to the right. Okay, so that is why I am writing R. Then from this 2 I am moving to 6, and that is why I am writing left L. Okay, so this is the shortest path. Okay, so see here, I am moving, let's say I want to move from this start and I want to move from this destination. Okay, so if I move here, then from here I move here, then from this one I move here, and then this from this two I move here. So this is the lowest common ancestor for both my start and destination. Okay, so first thing is that we have to find the lowest common ancestor for both 3 and 6. Okay, for both our start value and destination value. What is the lowest common ancestor? Because using that lowest common ancestor we are going to find the shortest path now. So here let's say there is one tree, right? From 1 I am moving to this 2, and from 2 I am moving to this 4, and then from this 2 I am moving to 5, then from this 5 I am moving to 6, from this 6 I am moving to 7. Okay, something like that, it's there. Okay, so I want this, let's say this is my start and this is my destination. Okay, so for both of them the lowest common ancestor is 2 now, so definitely my path is going to be like this: 1 2 4. Okay, so this is going to be my path, right? So definitely first thing that I need to do is find the lowest common ancestor. Okay, so now how I'm going to find the lowest common ancestor? So let's see. So initially let's say if this is my starting point, okay, this is my root, and this root itself is null, and if this root itself is null, then definitely from here only I'm going to just return null. Okay, so here let's say I'm going to create one method here. Okay, so first I'm going to write the code for lowest common ancestor. Okay, then I will explain what is happening here. Okay, because only then you guys will get the clear idea. Okay, so first thing, see here, I have to search for this node now. What is the lowest common ancestor node? So here I'm going to create one method. Let's name it as private, and since I'm returning node, so that is why I'm writing 3 node, and here let's write find LCA, lowest common ancestor, and inside this just pass whatever my root and whatever my start value and whatever my destination value. Okay, all these things just pass that. And now initially I'm saying that if my root is null, then simply return. Okay, if my root is equal to null, then in that case simply return null. Okay, that's it. And now let's say there are 2 nodes. Okay, there is one node 1, and then 1 after that there is 1 4. Okay, and let's say this is my start and this is my destination. Okay, so now initially let's say my root is at this position. Okay, so if my root dot value matches with this start, okay, then in simply means that this is going to be my lowest common ancestor, right? So from here only I have to start then, right? Here I am finding the lowest common ancestor now, lowest common ancestor. So here if there are just 2 nodes and this start and destination, and that root dot value matches with this start, then definitely simply means that this is going to become my lowest common ancestor initially only. Okay, so that is why I write few more base conditions here, right? If root dot var is equal to start value, or if my root dot value is equal to this destination value, then in that case simply return root. Okay, that is going to become my lowest common ancestor. Return root, that's it. Okay, This is done. Then after that I have to move to the left or right, okay, in search for this my start value and destination value. Okay, so let's say if I move to the left, okay, and what I'm searching for the node. So here I am writing tree node left, and then I'm going to call this one method, okay, and then if I move to the right, then I have to call one method. Okay, so if I am moving to the left, okay, if I am moving to the left, then here just call this method find LCA. I'm calling this method again. Okay, now I'm moving to the left. Okay, so here for left, then my root will become the root.left. Okay, root.left, and start value is going to remain same, and my destination value is going to remain same, destination value. Okay, now if I move to the right, then again I have to call this method find LCA, and then this will become a root.right, and here this is going to become my start value, and here it is going to become my destination value. Okay, that's it. So now see what is happening here. So let me copy this example here. So 5 1 3 and 2 6 4. Okay, so let me draw this. 5 1 3, here it's 2, and here it's 6, and here it is 4. Okay, initially my root is at this position, right? Initially my root is this position, and this is going to be my start, and this is going to be my destination. Okay, so now let's see what is happening here. So initially my root is equal to null. No, it is not equal to null. Okay, so I'm not going to execute this step. Now after that I'm checking if my root dot value is equal to start value, or is it equal to destination value. So no, it is not equal to start or destination value. So what I'm doing after that, I am moving to the left side. Okay, so now this is going to become my new root. Okay, this is going to become my root. Okay, so that's it. So here I have removed this part. So now this is my root. Okay, again I have to check for these conditions now. Root is equal to null? No. This value is satisfied? No. So what I am going to do, again I am moving to the left of this node. Okay, so now this is going to become my root. Okay, so here I will remove this part. Now see, this root is equal to null. No, this part is not executed. Now this value is satisfied. Root dot value is equal to start value. This is OR operation, right? So here from here I am simply returning the root. So what is my root? 3. So here I am simply returning the 3 value. Okay, 3 node. Okay, that's it. So from here I am simply going to return 3, right? So here let me draw it like this. So here I am simply returning 3. So here my left 3 node left value, uh, this is going to give me the output as 3. Okay, so 3 node left is going to give me the value as this 3. Okay, this is done. Now after that I am going to execute this part. Okay, so here I am going to move to the right direction. Okay, so here see, this is the one. Okay, I have already returned from this 3. Okay, so this is the one. So for this one in the right, there is nothing, null. Okay, if there is nothing, null. Okay, so I am simply going to return null. I am simply going to return null from this part. Okay, so see here, right now in this part my left is giving me 3 and my right is giving me null. Okay, this is what's happening here, right? Left is returning me 3 and my right is returning me null. Okay, so now what I'm going to do, I have to execute further now. So I want to pass some values now here. Okay, at 1 I'm getting L is 3 and R null. So what I'm going to do here, so after this I'm just going to return if my left is not equal to null, then in that case I am just going to simply return left, otherwise I am going to just return right. Okay, that's it. So at this particular position I have returned my left as 3. That's it. Now after that I have to search in the right of this 5. Okay, I have already executed this part. L is equal to 3 I have executed. Now I move further. I move to this. So this is going to become my root. So this root is equal to null. No, this part is also not satisfied. Okay, this is not satisfied. Then after that this is going to be executed. Okay, so now my root is going to become this part. Okay, my root is going to become this part. Okay, so now what will happen? So this value is equal to null. No, but this condition is satisfied. Root dot value is to destination value. So from here I'm just going to return simply 6. It is returning me 6. Then after that I have to check in the right of this 2. Okay, so I move to this position. Okay, and here inside this is not matching. So simply this is going to return me null. Okay, nothing here. tr is going to give me null. Okay, tr is going to give me null here. Okay, nothing. So here at this position you will see that my TL that I am returning from here is 6, and my TR that I am returning from here is nothing but null. Okay, at this particular position. Now I move backward. Here. So at this part, okay, at this part again I have to check. At this part here, my TL is equal to 6 and my TR is equal to null. Okay, so here I am going to return the this value, right, 6 value. Okay, so right now if both at this particular 5, you will see that my L is equal to 3, my R is equal to 6. Okay, so if that is the case, then from here I am simply going to return. Okay, so if my left is not equal to null, if left is not equal to null and my right is not equal to null, okay, if this is the condition, then simply return the root. Okay, this is what I need to do. Okay, so like in this case na, TL was 6 and TR node right was not giving them null. So I execute this part. After this I execute this part, right? So if my left is not equal to null, so I am going to return left, otherwise I am going to return 6. So from here simply I have returned 6 here to this part, and this 6 is nothing but my right, this 6 is nothing but the output of my right. Okay, so now after that I see that both my left and both my right are not equal to null, then simply in that case I am going to return the root. Okay, so 5 is my root. Okay, so here 5 simply means that this is going to be my lowest common ancestor. Okay, that's it. So I hope that this code is clear to you guys. Okay, so that's the part of this from line number 5 to line number 18. This is the code to find the lowest common ancestor. Okay, so let me write a comment: lowest common ancestor. So after finding the lowest common ancestor, we have to do few more things, right? So like in this example one, we have found out that this is going to be my lowest common ancestor. Okay, so from this lowest common ancestor, from this point only I have to start. Okay, so like in this example, if I found that this is my lowest common ancestor, so from this only I have to start now. I don't need to check for these things, right? So similarly for this, I am going to start from this position. I am going to find my start, and then again from same position I have to find my destination. Okay, so first thing is that for this 5, okay, if this is my starting point, then I am finding this 3 in this direction. From 5 I am moving to 1, I am moving to 3. Okay, so I am moving L direction, then again L direction. Okay, and if I move from 5 to our destination, then 5 to 6, this is the part. So here 5 to 2 is R and 2 to 6 is L. Okay, so in the end what I'm going to do, instead of this LL, I am just going, we need to move from start to destination. Now we need to move from start to destination, right? But what I'm doing, I am in this path I am moving like this, and here also I am moving like this. So I have to just reverse this now, because I need to move from this starting point to this one. Okay, not from this point to this point. Okay, so what I'm going to do, instead of this LL, I am going to change it to UU. That's it. Okay, because we need to move from start to LCA, not LCA to start, right? So that is why I have to just change UU in that. Okay, so now let's write the code actually. So here first we have to find the this LCA na. So simple, here we have already written the code for finding the LCA. So let me zoom the screen. 3 node LCA is equal to 3 node LCA is equal to, just call this method. Okay, find LCA, and in this just pass my root, my start value, and my destination value. That's it. Okay, this is now this is going to give me the lowest common ancestor. That's it. Now after that we have to build the paths, right? So here see, in this example I am building this path. So this is nothing but from this path is nothing but from my start value to my from my start value to my LCA na. This is what I need, but here LL I'm writing, so that simply means from LCA to start, right? And here what I'm doing, LCA to DD, destination. Okay, so here let's create a string builder. Okay, two paths I'm going to create: string builder Let's name first one as path to start. Path to start. Okay, so first I am going to find the path to start. Okay, so from LCA to source. Okay, path to start. So here I am going to write string builder path to start is equal to new string builder, and same way string builder path to destination is equal to new string builder. Okay, this is done. Okay, so I have to find these two paths. Okay, so now I am going to call one method find path. Okay, I am hoping that this path is going to give me the path like this, LL and RL. Okay, so find path. So in this find path method I am passing my start, that is root. Okay, LCA is a root, right, lowest common ancestor, and I need to move from start value. Okay, and I need to move to my path to start. Okay, this is what I need to pass, path to start. Okay, LCA to start value I have to move, and path to start here I have to just store the path. That's it. And same way find path, my starting point is LCA, my destination point is dest value. Okay, and here I'm just going to store my path to destination. Okay, so now let's write the code for this. Let's write the code for this find path. Okay, so let me write the code here. So I am going to create one boolean method. Okay, private boolean, and here find path, and I am passing my starting as the root, right, tree node root. Then I am passing my start value, right. So let me just copy paste few things here. So here what I need my root, then I need one value, so let's name it as value. Okay, value, int value, and here this is nothing but my path to start is nothing but my string builder, na? So here let's write string builder, and here instead of this path to start let's just write path. Okay, so using this same method I'm going to get the path. Okay, that's it. Now inside this, if my root is equal to null, okay, then simply return false. Okay, then there is no path. If root is equal to null, then there is not going to be any path. So here I'm just going to return false. Okay, now after that, if my root dot value, if the root dot val is equal to value, okay, that simply means that we have to return true. Okay, that simply means that we have found the path. Return true. Okay, because from root I have to reach to the start value, destination value now. So if I reach there, root dot value becomes this one, that simply means that there is one path. Okay, return true. That's it. Now after that, here see, from 5 I am moving to the left, right. So if I am moving to the left, then I have to add L, right. So here what I am going to do, here in my string builder path dot append, and here I'm just appending this L character. Okay, after appending I am going to check if this method find path method, if I move to the left side, root dot left, and here some value is there, and here my path is there. Okay, okay, so if this becomes true in any case, okay, so right now see here I am at this position 5, then I see that my root is equal to null. No, so this case is not executed. Root dot value is equal to value. No, this case is not executed. Then I have added L here, path dot append L. Okay, so I have added L here. Then after that I am going to check, I'm again calling this method in this if block. If find path, I move to the left side, right. So now I move to this position, this is going to become my root. Okay, so now This root is equal to null, no, false, it's not executed. This is equal to value, no, this is not executed. Then again I have added L, so here I have added L one more time. Then I reach to this position, okay, this 3. Now again find dot path root dot left, again I passed, so this is not equal to null. Okay, if root dot value is equal to value, now it is going to return true. Okay, so it is simply going to return true. And what we have LL in our case, right? So this is what we need to do. So if it is going to give me true output in any case, then simply I'm going to return true here. That's it. Okay. Okay, this is done. Then after that, if there is no path, like if let's say after this 3 I reach somewhere some node 4, and this is not 3 but 5, and 3 is here at this position. Okay, so from here I'm going to return null. Then I have to check in the right as well, na? So simply here I have added L one time after moving from 5 to this 4. Okay, so what I'm going to do here, I'm going to just remove the last character. Okay, so path dot delete char at path dot length -1. Okay, because I have to move to the right. Okay, if I didn't find any path. So this is done. Then after that, again we have to do the same things for the right. Path dot append. Now this time just add R, and if root dot right here. Okay, and return true. If we didn't find any path, then just call this one again. Okay, and in the end simply return false. If we didn't find any path, return false. Okay, so I hope that this code is clear. So from here we are going to get the paths like this, LL and RL. But in the end I have to just change this LL to UU now, because I'm moving from LCA to start, lowest common ancestor to start, but I need to move from start to lowest common ancestor. So what I'm going to do here, I'm going to convert the path to start into use. Okay, so here I'm going to create one string builder result, and in okay, this is done. New string builder, and then I'm just going to run one loop for int I is equal to 0, I is less than path to start dot length, and increment the I, and simply I'm going to append u, result dot append. Okay, simply I'm changing the u now, changing it to u. That's it. So what I'm doing here, LL length is 2 now, so I'm running one loop 2 times, and instead of LL I'm simply writing UU. That's it. Then whatever the result that I have got here, in that result I'm just going to add result dot append, but we need to add this path to destination. That's it. Path to destination is going to same, and then in the end just return this result, and let's change this string builder to string. That's it. Now let's run the code. Code is very simple actually for this one. Just go over code 2-3 times, okay, and then practice, then it will make you perfect. Okay, now let's submit it. So see, our solution is accepted, right? Okay, so now see here, let me go over code one more time. First thing that I'm doing here, I'm finding the lowest common ancestor. Okay, so see here, this is a code for lowest common ancestor. Okay, so this is going to give me the lowest common ancestor. Then after that I am doing this string builder command. I am finding path to start and path to destination. Okay, so here see path to start or path to destination. So here in this part, if my root is gonna returning false, if my root dot value becomes value, then I'm returning true simply. Otherwise I'm simply appending LLL. Okay, every time until this case is executed. Okay, so if I didn't find anything, okay, in the left side, okay, if this statement doesn't become true any case, then definitely I have to change the way, right? So see here, like from 5 I need to move 4, then here I've added L one time. Okay, but 3 is there in the right of this one, so I'm moving back. So from moving back I'm just going to delete this L, and then I'm searching for the right of this 5. Okay, so that is why I have to delete this. Same way I have to do this for R. Okay, that's it. So this is going to give me the path. Then after that since we are doing LCA to start, so I need to change the path from start to LCA. So that is why first LL I'm then converting it to UU. So this is what I am doing here. Then in the end, I'm just adding RL in this UU. Okay, so that's it. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.